Hi everyone, hopefully that you can hear me now. I know that we had everyone out waiting in a lobby. That's just so that we can prepare a couple of things and make sure when you come in it's all ready for you to go. So I noticed that I should introduce myself really quickly. I'm Christy Marshall. I'm from the marketing team at Snowden. So I'm the one that's been sending you all the emails with your details. And if you do have any questions or issues, during the session, send me a message. Tag me in the chat, private message, or you can email me at christy.marshall@snowden.com if you have any issues. But yeah, so we're just going to do a couple of things before we get started. We're going to wait a couple of minutes to make sure that we've got pretty much everyone in, give everyone a few minutes. We've got about 142 and counting. So we've got a lot more people than that registered. So what I'm going to do is just start off with, we have a little bit of a survey to get started. Just a couple of questions for us to get to know you and see who's on the call. So if you are already in the chat, you're live here. You'll see on the main screen here that there's a couple of questions, so you can just click through. Got some answers already, which is great. And just one thing I wanted to mention really quickly, some of you will have seen emails from me just mentioning we've changed the software that we use for webinars recently. So we're on GetResponse right now, which is a really great tool. We can do everything we need to make sure that we actually get the recording. We did have some issues with WebEx in the past, but what that does mean is because we're kind of in between using two different systems, I think there's a little bit of an issue that some of you have been logged in using my name. So we've got quite a few Christies here. I noticed that some of you were able to change your name. So if you're able to do so, please do. But otherwise, that's all good. If you have any questions, feel free to just, drop in the chat box, hi, state your name, where you're from, and then let us know your question. So give us a couple of minutes to do that, just to do this survey, and then we'll get started.
Great, thanks, Christy. And yeah, hello everyone. I'm Anthony Cook, Snowden Product Manager for Supervisor. It's great that you could all attend. I'm looking forward to listening to Oscar just as much as you all are. And yeah, looking forward to some good discussion and questions and talking about multivariate simulation. So Christy, we also have the option to allow chat to have questions as well. Is that right?
Yes, so we've got a couple of different options, which is really great. So as we go through the session today, just feel free to drop any questions that you've got. We will get to them at the end. So we're going to let Oscar kind of go through and talk us through his presentation today. And then when we get to the end, we'll do a bit of a facilitated Q&A. So I'll pop the questions up on the screen. We'll, obviously we'll have a lot of different questions. Some will be repeated, but yeah, we'll pick them out and we'll answer them at the end. So feel free to drop them in at any point during the session. There's a couple of different things, a couple of features that you can use as well, which are really handy. Just a quick note that everyone who is on the call, all your audio and video is switched off. So you don't have to worry about accidentally being unmuted because there's two layers there. Like we have to unlock individuals and then you can unlock your own. So no stress with that. We don't have to worry about anyone, little bit of background noise. You can just in the chat box on the right hand side, you've got a little hand symbol, so you can raise your hand, agree, disagree. You can change the volume or speak louder, speak softer, or select that you need help. So if you have any questions, you can do that to let me know. If you can't hear anything or see anything, then there'll probably be a couple of different settings that you need to adjust there as well. Just looking through comments. All right, so just really quickly, let me know that you can hear anything or if you're having any issues. A little bit confusing.
I think we've managed to get 2 Oscars.
Oh dear. All right. People can hear pretty well. It might be a case of you need to turn the settings on for your browser. So yeah. Again, apologies for the naming issue. This is just a little bit of a glitch between using a couple of different systems as we're changing over. So Christy has just said, can hear once clicking unmute.
So for those that can't hear, maybe it's worth typing something into the box for them. I'm not sure where the settings are for most people. So I get mine on my AV pod.
All right, so someone has just said they can hear once clicking unmute. So what I'm going to do is swap over to Oscar to get started in a minute. If you haven't, completed the survey, then just click through, and I'll swap over to Oscar in a minute, and then I'll make sure to jump in and help everyone. So Oscar, as a lot of you know, is a principal geostatistician at Snowden, so has been at the company a couple of different times over the years. He is a skilled geostatistician and researcher with over 18 years of combined experience in oil, gas, and mining industries. We're really lucky to have Oscar on our team and also here presenting today. Obviously, we've got Anthony here as well, who is a geologist and product manager for supervisor and training, as he mentioned already. Anthony's got over 10 years in the industry. Last couple of years, Anthony's been at Snowden helping us, obviously, with supervisor. And so Anthony and Oscar work together on supervisor. So, and obviously a lot more than that as well. So I'm going to swap over to Oscar, and I'll just jump in to help anyone who's having any tech issues there.
Just before we do, is it worth having a look at the results of the survey? I'm quite curious.
Sure.
Just so we can get to know who we've got in the audience.
Yes, I'll just swap that over. So
fantastic.
I had 90% vote. So we've got a lot from Asia Pacific, some from Europe. We've got some from North America and Central and South America, which is really great. I know that time zone wise is a little bit tricky. And a good mix of attendees who are supervisor users and some who aren't as well. Using multivariate simulations, so 63% said no. And then how many years experience do you have in geostats? Again, a really good mix of people with different levels of experience. So yeah, we've designed that with this kind of variety in mind, I guess. This isn't, as far as I know, a really deep dive technical experience. So I'm going to swap and leave this to you, Anthony and Oscar. And
I'm quite impressed that there's about 20% of the people online that are using it. So it'd be very interesting to hear your questions later on.
So just to double check, can you hear me, Anthony and Christy? Can you hear me well? Or?
Yes. Yeah.
Yep. Oh, good.
So you probably just speak up during the presentation, but it's fine coming through on my end.
Yep. Okay. So fine. Are we ready, Christy? Yep. Need to. Okay. So yeah, thank you, Christy, for the introduction, and thank you to people attending this webinar. I'm really pleased to see all these people interested in multivariate conditional simulation. What I'm gonna do now during the presentations, I'm gonna switch off my camera just to get focused on the presentation. During the questions and answers, I'm gonna switch back on the camera so we can discuss and go through the Q&A session. So I would like to start this presentation making some acknowledgement. And first, I would Snowden would like to thank our client for granting the permission to discuss the results. And these are partial results of a study that we did. And if you understand, the details must remain anonymous at all time. So don't be surprised that I have data with no scales, no spatial locations. So I had to remove all the confidential information. And I also would like to acknowledge the work of my colleagues, Anthony Cook and John Grandor. It was a really challenging project, a lot of work and team effort, and we had really good fun along the way, which is great. So what I'm planning to talk today is about multivariate simulation, a particular application of multivariate simulation. And I would like to discuss why we had to use multivariate simulation. I'm going to describe the workflow used, and I'm going to finish giving you an idea of what is coming in Supervisor on multivariate simulation. So how can we use multivariate simulation? This is a very particularly example. We can use conditional simulations, so there are many applications of conditional simulation. In this example, the idea is to relate the drill-grill spacing with the cost of misclassification. And what we are doing is defining the misclassification loss as a function of ore loss and dilution, and taking into account processing cost, metal price per ton, and the recovery percent. So why we need a multivariate simulation approach? The data that we had is data that comes from an iron ore deposit. We got 4 attributes, and as you can see on the scatter plots on the right, the data is highly nonlinear, and we got also something that is really clear, what is called a closure. So we got a compositional nature. So if we carry out this study only taking into account the iron grades, we'll disregard all these important relationships. I'm gonna show you, for instance, some of the scatter plots. There you can see the different scatter plots. It's very clear the compositional nature of the data when you look at the scatter plot of iron and silica, iron and alumina, and quickly we realize that we have a complex data set where we have nonlinear correlations, and we got a compositional problem here, as I mentioned before. So just a reminder that if we are naive and try to run conditional simulation, let's say for iron and silica, we will soon have a problem. You can see on the scatter on the right that we are not able to reproduce the closure, not able to reproduce the relation between iron and silica, and that we are creating data that is unrealistic. We may have a block, for instance, with 80% or 70% iron and 50% silica, which is not correct. So as I mentioned before, now that we know that we have complex linear relationships, then we realize that the simulation should take into account all these plus the compositional nature of the data. So we have to move on from standard techniques, and I can say we have to move on from PCA, math, collocated co-kriging. You know, we need to work with more advanced techniques that transform the data to independent components. To do that, we have mainly 2 techniques. We got flow anamorphosis, which is a recently technique put together by Uta Mueller out of the ECU, Eddie Cowan University. And we also have projection pursue PPNT based on the original work of Freeman and Tukey from Barnett et al. Out of the CCG in Alberta, Canada. When we went through the techniques, we quickly realized that flow anamorphosis is the right technique to use with compositional data. And it's mainly because of the affine equivariant property. But we soon realized that the technique is impractical, at least for the case study that we were using because of the large simulation model we were about to run. So we had a lot of data, large block models. The simulation that took too much time to transfer the data. So then we look at PPNT. PPNT was great. We got overall processing a lot lower, minimal tuning parameters, and that's the technique we use to run the results are about to mention. But what I would like to show you is that both flow anamorphosis and PPNT are based on similar concepts, and the idea is just transform the data into independent factors. How you transfer the data is the main difference between the two techniques, but basically what we are doing, the way to run the conditional simulations is, suppose that we have the input data on the top left. That is data coming from a nickel laterite deposit. What we have to do is just take the data and transfer that into independent Gaussian factors. Once we have independent Gaussian factors, then we can run univariate conditional simulation. We run the simulations, we got the red dots there, and then what we have to do is just back transform to reintroduce the data. Reintroduce the relationship between the data. So the workflow used is quite simple. It's a long workflow, but it's very simple. Mainly, we have to look at the data and decide on a compositional transformation. In this case, working with iron ore data, we believe what we call the filler attribute is important. And the compositional transformation that we used was the additive log ratio. Once we have the data on we remove the compositional constraint, then we apply the multivariate transformation. That's where the PPNT comes into play. And then we get the factors. As you can see along the workflow, we have several validation steps. And I would like to highlight here that it's important for this multivariate simulation workflow to carry out many validations, mainly on the factors. The quality of the results in the simulation depend on the factors and the factor simulation. So once we have the factors, we validate the factors, and I'm gonna give you an example of that. We simulate and validate, then once we validate all the simulations, we back transform and simulate in real space. Now that we have all the geostatistical components and all the simulation, that's where the real fun begins. So we have all the pieces, and what we have to do is just sampling. And by sampling, I mean we can create pseudo drill holes at the different drill spacing. We can use all that information to carry out estimation, and then we can get our simulation, do reblocking, and compare. With all that information, we can create a series of scenarios for our client to analyze the scenarios and come with an outcome. So what we have to do to validate the factors. First, we need to check that the factors have multivariate Gaussian distribution. So we need to check that the univariate distributions are Gaussian and that they have no correlation. When you see the scatter plots on the left, we can see clearly that we have 4 factors and all of them show no correlation at all. The next step is we check the cross correlation between factors. Remember, when we check the correlation, we don't check the spatial correlation. With this sort of technique, we can guarantee we have 0 correlation, or we have no correlation at lag distance 0, but we need to check the spatial correlation. As you can see, the graph on the right, we have almost no correlation, and when you see the one at the top right, There is some sort of correlation here, but if you look close, you will see that, for instance, for the first 300 meters, there is a spatial correlation of 0.3. So we consider that as uncorrelated, and then we proceed to run the simulation and use the factors. So after running the simulations with the factors, we check that the simulated factors are uncorrelated. You see here on the right, the previous graph, on the left, the previous graph I mentioned, and on the right, you see the simulations and the scatter plot with the simulations result for the factors. Something that you can see clearly here is the confidence circle for the Gaussian distribution. Most of the points are towards the center of the circle, and few points are away from the center. Now that we have the factors validated and we carry out the back transformation, we need to check the simulation in real space, in real grade data. Here I'm showing you an example of univariate statistics, the histogram. On blue, you have the drill hole data. On red is one simulation. We can see that the simulation for iron and silica reproduce really nice the drill hole data. On the next one, you see we got the log histogram for aluminum and manganese. We see there as well that the simulation reproduce really well the drill hole data. That's mainly for univariate stats. Then we can move on and check the scatter plot, see if we manage to reproduce the compositional nature of the data and the simulations. On the left, you see the drill hole data, the original input correlations for the drill holes, and on the right, you see the model. You can see that the simulations nicely reproduce the compositional nature of the data and the highly nonlinear correlations. Another validation is to have a look at different sections. On the left, you see two different simulations and compared with the drill holes. Again, one validation where we showed that the simulations reproduce quite nicely the drill hole data. On the right, it is an example of the reproduction of the cross variogram. I have two simulations, the ones that are really smooth, the red and purple, and the other one is the experimental variogram or the cross experimental variogram between iron and silica. So after all these validations, we are, happy that the results that we have reproduce the drill hole data quite well. So what we have to do now, that's, as I mentioned before, is when all the work begins. Now we have many drill holes, many simulations, and then we can start analyzing the scenarios using the different drill spacings and the different functions that I mentioned before, like recovery percent and processing cost. By having a look at those graphs, I'm pretty sure you can imagine, or you can guess where the tighter drill spacing is. But that's mainly what we have to do. So we run all the simulations, we go the drill hole data, we go the pseudo drill holes, and then we can start creating scenarios to analyze the misclassification cost. So what is the Snowden take on multivariate simulation? Where at Snowden, we want to provide you a simple, concisive, and very easy software. So basically, we want to give you something that you can use and go through a high-level technique like this in a very simple way. So when I say that is simple way, it means you got your software, You got your data, you got your multivariate data, right-click, insert multivariate simulation. And then supervisor adds all the necessary components, preload with reasonable defaults. And what I'm referring to is we insert the multivariate simulation, and then immediately we have compositional transformations available. We go the transformation to get into factors. We reblock the simulations, compute the variance, and we do this on a domain-by-domain basis. So after inserting the multivariate simulation, that's what I mentioned before, you can have where you decide what sort of compositional transformation you want to use, and the transformation to get the data into factors. At the moment, we have multivariate PPNT, or multivariate transformation implemented, coupled with math transform. But we also have another technique that I would like to discuss for a minute. We call that just simply multivariate Gaussian transformation. The details of the technique are going to be presented during the next Geostat conference. And the idea to talk about this is because PPNT is great. We have been using PPNT a lot, but during the course of several projects, we found that in some cases, and I'm saying here this is really difficult data, PPNT was having issues Gaussianizing the data, creating the factors. And what we soon realized is that with little modifications, we can create a technique that produces better Gaussian results and can handle a lot more data. So here on the graph on the left, you see that the results are not too bad, but the one on the top, on the bottom left is not real Gaussian. And on the right, you see the comparison with the new technique. In here, what we did is say, well, now that we know that we can Gaussianize the data, we transform the data into Gaussian, how quickly can we do that? So what we did is just at every iteration of the process for the multivariate Gaussian transformation and for PPNT, we were running a statistical test and see if the statistical test reports that the data is multi-Gaussian. As you can see here on the presentation, if you go to a p-value of 0.1, let's say a level of 10%, around 20 or 15 iterations, the multi-Gaussian transformation already reports multivariate Gaussian data, while PPAT takes a bit longer. Now, if we compare, for instance, with data size, what we quickly realize is that with really large data sets, the multi-Gaussian transformation was running quite fast compared to PPNT. So what I'm saying here that for our users, for our supervisors users, now you have a really good tool. You have multivariate simulation with all the compositional transformation if required. You got a really nice technique like PPNT, and you got an extra option that runs faster and Gaussianize the data really quickly compared to PPNT. If your data set is reasonable size, both techniques are similar. But if you have something that is really, really large, with thousands and thousands of points and millions of log models, you got the option to run the multivariate Gaussian transformations to run the simulations. And I guess that's it for me. I'm gonna switch my camera back on, and I'm looking forward to all your questions.
Thanks, Oscar. Christy here again. So I am going to just switch to Q&A mode.
Yep.
We have a really handy feature where we can just add our questions. So I'm going to go through, thanks so much for your presentation. I think that the Q&A section is something we expected to take up a fair bit of time because obviously there are some very technical questions that people had, popped through. So I'm just going to drop one at a time. And don't mind me, I'm not a technical person. I'm in marketing myself. So I'll read out the questions and then I'll leave it up to you, Oscar, to actually obviously answer them. So Let's get started. And if anyone, if you didn't get a chance to ask your questions yet, please drop them in. We have plenty of time still, 20 or so minutes to keep going through. So drop them in now and we'll get through. All right, I'm going to publish this first question. So the histograms and scatter plots looked like typical iron ore data that has not been segregated into mineralized and unmineralized domains. Would the workflow have benefited by further construction of geological domains rather than using the transformations?
I might be able to comment on that one. Yeah. So it was domained into geological domains based on mineralization. This particular one, and one of the reasons we did the study on this data set, was that it is quite a complex and, for lack of a better word, patchy data set. And, for the level of the study, it wouldn't have been valuable to the company to do further geological domaining without first doing the study. So, sometimes you don't get the benefit of nice data sets, and it was, the outcome that we got was actually very impressive considering the complexities that went into the data.
Great, so we have a bunch more questions. Let me keep going through. I'm not sure if I should go through in order, so let me just publish the next one. Hopefully that only takes a second.
Yep.
Can this be used for AS, for example, in a float high grind process?
No, I'm not sure. Anthony, do you have any comments on that?
Well, I suppose, Oscar, the question really is multivariate simulation restricted to assay data, or can it be used for other variables that are correlated?
Yeah, sure. Yep.
Yep. So I suppose the answer to this question really is, if you can prove correlation or composition between the samples that or the variables that you're measuring, then I personally don't see a reason why it couldn't. As always, check your results, have a look, do they make sense? And if the technique works for that application, brilliant.
Yep.
All right, publishing our next question. It seems to take just a minute or so to do that. So I spoke to Anthony about sampling utility for sampling simulations, and I thought he said it was not in Supervisor. Is there going to be a simulation?
So the implementation in Supervisor is only up to the point of producing and validating the multivariate transformations. There is some scope for implementing that kind of sampling, but not in the near future, I would say.
Sorry, there's a little bit of a delay with pushing these through to be published. And obviously, just checking.
Getting a few people that say they can't hear me. Let me just toggle my audio.
I can hear you all good, so there might be.
Yeah.
Yep.
I've toggled my audio, but the recording should have all of the audio.
Yeah. If you are having any issues with hearing any of us, and I'll just drop this in the box as well, you can either log out and log back in, or maybe mute and unmute your own microphone. I know that seems strange, but someone did say that worked for them before.
Yep.
Next question, and I'll drop into the chat in a minute and answer any of those issues, but this process of MVS, has it been done using Supervisor? That was a little bit earlier, that question.
So I guess that's another one.
Yep.
Yes, multivariate simulation will be in Supervisor 8.14. So keep an eye out for that. I'm really keen we're getting close to being able to bring on some of our users and invite them to test out the process. I've just been told that I need some more T's and C's to be organized, but I'm very keen to invite all of our users to test it as soon as I can.
Yeah, look, Anthony, and I guess it's great to comment here that at Snowden, we work with produce our own codes, we produce our own results, and then we put that into the software. So yeah, the answer is yes. We got the multivariate simulation. As I said before, we use PPNT and the multivariate Gaussian transform, and we decorrelate using our own codes and run the simulations in supervisor, for sure.
All right, next question is, I did not think there was a sampling of simulation synthetic drill holes option at this time. Is that assumption incorrect, or is that option coming?
Yeah, so that's the same as the previous one.
Just let me make a quick comment here. It was my fault that I didn't mention when I showed the workflow that the sampling was done outside of supervisor. That's right. That's what Anthony mentioned. Yeah.
Okay.
That said, if there's enough need for it, absolutely, we'll look at bumping it up the feature list.
Great,
this one here. Yep, go for it, Christy. Sorry.
It's nice, big and bold on the screen anyway, obviously you can read it, but good so that it's not just you chatting the whole time. How did the total assay work out with PPMT and MGT?
Beauty, I would say, because we use compositional transformation. Actually, that's the, when you do the work and you run your compositional transformation, is exactly to preserve the total assay, and that's what we check. Yep.
Great. All right, next question. Is this multivariate simulation, or will it help to identify or omit the outliers of different radicals?
No, could be, but I don't know. Yeah, any comment on that, Anthony?
I would say that, again, it depends on the quality of your data going in. Any composition or any correlation that's in the data as it goes in will be reproduced. So the management of outliers or identifying outliers still needs to be done at the data step, because if you have true outliers in your data that shouldn't be in there, they will be reproduced and they will have a massive impact on the results.
Correct.
This question was actually quite early on. How well does the total assay validate? Have you checked?
You check that, Anthony? Yeah, of course.
Yeah. One of Oscar's slides where it showed the drill hole data versus the back transform simulations essentially shows exactly what we were hoping for, is that the total assays match very well with the input data.
Great. All right, next question. Has this process been compared against a more traditional LMC approach, or does the compositional relationship of this data set complicate its efficiency?
There are two things why I prefer to move away from a linear model of coregionalization. Remember, the linear model of coregionalization is based on covariance matrix. So we can handle, at most, linear correlations. And you are quite right, the compositional relationship complicates the efficiency of the process and the simulation, for sure. Yep.
Great, next question. So thank you to Somer, who put his name in as well, so we know that he's not another Christie. I think you need to increase the number of iterations during PPMT transformation to get a Gaussian shape. MAF is good when you still have correlation in your variogram in some lags.
Yeah, thank you, Samir. Yeah, look, in general, as I said, look, we had really great success with PPNT, and in most of the project we did, it worked fine. In that particular project that I showed the results, you increase the number of Gaussian or the number of iteration as much as you want, and you will get exactly the same result. That's why we had to start looking for something else that Gaussianize the data better. And you are quite right. If we apply math after, we can improve the correlation of the factors. That's fine. Yeah, but it's something that it needs to be checked. So, in my opinion, moving the data into independent factors, running univariate simulation is great. We have a lot of flexibility, but we need to check. So as I mentioned before, every time we use this technique, we need to check at every single step, and the validation of the cross-block and the cross-correlation is essential.
So this question was actually just in response to another question and answer that you provided. So the person has said, very good explanation. I have a further question. How much time do I need to realize a simulation for, which is 100 runs, a project, the area is, I'll let you read that, approximately.
Yeah. You can grab a share and wait, for sure. It will take some time.
It really comes down more to the number of nodes that you generate. So it's not so much the size of the area, it's how many nodes need to be generated. If you have 8 million nodes, you might have an hour. If you have 20 million, it might be much, much longer.
How do you select the best simulated values? Do you average these?
Great question. That's there is, in my opinion, there is no best simulated value. Remember, simulation gives you a range of possible values, and all of them share the same probability. So selecting only one, you need to be really careful, and you need to decide or define exactly what is best. So in this case, we didn't do any average of the simulation at all.
All right, next question. Are the simulated models reasonably interoperable with other programs?
Yes, so the models come out as very simple X, Y, Z, and values. So any should be usable with any software, CSVs, anything that can take those.
Great. All right, which software did Oscar use for the analysis, validations, and simulations shown at the beginning of the presentation?
Is that for the hex bin plots? So the hex bin plots, which most of the plots were showing, is not yet in Supervisor, but we're really keen to get hex bin plots into Supervisor because, in my personal opinion, they show one of the best representations, particularly when you have so much data. And you'll notice the difference between the black scatter plots, which Oscar showed, and the hex bin plots. So they were done outside of Supervisor. It was just using RStudio, which is an open source software, which is quite popular for statistics, but it's something that we'll be bringing into Supervisor as soon as we can, and you'll be able to generate plots just like that.
All right, great. We've still got a couple more questions, so let's keep moving through. Can this be used on 20 different elemental assays of each sample in a rare earth element project?
Look at, say, the technique. For the technique, the number of attributes is not an issue. So it's something that it can be done really quick, the transformation. And here with Anthony as well, what you need to make sure is that what you are doing with the technique is correct or is appropriate for the project that you have. But in principle, yes, the number of attributes is not a problem.
It more comes down to a practical standpoint, because remember that you do need to run simulations on every single assay, every single variable, and a number of realizations if that's the case as well. So we've actually bringing in some smarts into Supervisor, which will allow you to generate more simulations in less time than would be normally the case, and we're working on that. But I guess the other thing that I noticed while doing these projects is that if you have trace elements, then they can vary by quite a lot, or they can influence some of the larger elements if they happen to vary quite a lot. And so be very cautious about the quality of the data that goes in. And in general, the more composition each variable has, the better result for that variable. And if all of them are aligned, you get a much better result too. So possible, yes. Necessary, maybe something to think about.
All right, so next question. How do you arrive at the factors? The requirement for there being no correlation between factors sounds very much like Hermite, I actually don't know.
Polynomials.
And Craigie, marketer here, don't mind me not knowing all this.
That's okay. That's very technical, Christy. No, look, normal polynomials, no disjunctive Kriging at all. Basically, it's just the transformation, as I mentioned, flow anamorphosis, PPNT, and multivariate Gaussian transformations are truly multivariate transformation that take your drill hole data and give you the factors. Yeah. So no Hermite polynomials, no disjunctive Kriging.
All right. Some really great questions, actually. How do you handle data sets where there is not a full set of data for each variable?
Yeah, excellent question. Yeah. So initially, the best way to go if you have homotopic data. So at every single location, you have every single value of the attributes that you need to simulate. If that's not the case, then you need to make decisions of, what I call Coachman just calls. One way to go is imputation, for sure. Some people like imputation, and some other people don't like. But for simulation and running different scenarios, imputation is the way to go.
Great. Next question. Conditional simulation works only in regular blocks or also in subcells?
You want to take that one, Antonio?
Our conditional simulation is based on, well, it's nodes, it's point simulation, which then gets reblocked into regular blocks. It would be outside of supervisor to incorporate subcelling. But if you do load in a subcelled model, it uses the small subcelling and generates the nodes based on that, which can then be reblocked to any size.
Yep. So.
All right, so what about the direct block for very large simulations? Is this on the horizon?
It could be. Direct block simulation is faster, but remember what we are doing here, particularly in this example, we need to take into account all these correlations, compositional nature. So it's going to be a real challenge for direct block simulation to produce results like the one I show here, but yeah, it could be on the horizon. It's a great technique, and it could be the way to go if we want to run simulations really, really fast. Yeah.
Great. If in my data set, the histogram showing a bimodal distribution of radical for Phi and SI, how will MS help on this? Or how would I choose which method of simulation is correct?
So I guess Anthony mentioned here, so if you have something that is bimodal, remember, here we have the technique, as the usual people and we practitioners say, if you have garbage in, garbage out, so you need to look after your data, you need to correct your data and make sure everything is fine. But I don't know if you notice on the histogram I showed, you can see some, you can make some interpretation, say we got like a bimodal population here, and the simulation were reproducing that just as a beauty. I mean, it was really nice. We were happy with that distribution. We understood why those values were there. But my advice is that if you just work with your data, understand your data, and then use the technique.
Next question. Any possibility to add a blind test?
I read that one, but I didn't understand the question. Sorry.
I think it was referring to an earlier question.
Yeah, I might need more specifics on that. We can definitely add any tests that are necessary for validation purposes. Usually it's just communicating exactly what those tests are and there's no problem.
So whoever it was that did drop that question, obviously not Christy, then please just add a little bit more text.
It said it was Christy.
Yeah, pretty much all of them.
Yeah.
All right, next question. This method is different to Gaussian, collocated, excuse me, co-simulation and or stepwise simulation.
Oh yeah, sure, quite different. Yeah, it's very different. Remember that collocated co-kriging as an estimation technique is great, but for simulation, the collocated simulation has an issue, and is the inflation of the variance. There are some, ways to deal with that, but you have to be really careful. But let's say in summary, yes, they are very different to collocated simulation and stepwise.
Great. Are other simulation methods going to be implemented in the future, like turning bands or indicator?
Yeah, indicator is one that's high on the list. It just takes a bit of work to get it implemented. So I don't have a timeline for that one, but I'm keen to see that one. Turning bands seems to be more of a niche sort of simulation technique. We're not getting a lot of demand for turning bands, but again, supervisor, we're really focusing on bringing the most practical techniques and the easiest interfaces we can. So we want to ensure that the things that we have right now are extremely practical and easy to use before we overload on several different techniques at the start.
Makes sense. All right, so last technical question, then we have just a couple of comments, but what about using external well information with different support?
So you mean, for instance, to using a secondary data and sort of. We haven't done that with the technique. My worry is the different support. So it's something that needs to be handled well before running the simulation. But no, I haven't done it.
Okay, great. Look, that's all the technical questions that we've got. If anyone else did have any other questions, drop them in now. Obviously, you can reach out to us after as well. We had a couple of comments from people saying, really enjoying the presentation, asking if we will be doing more webinars in the future. The answer is yes. So this is something that we started wanting to do more of, obviously, because, moving online and us not being able to do in-person training courses and various things with COVID. But definitely it's something that we'd really like to continue doing, and obviously it's been very well received. We had nearly 700 registrations for this webinar, which is amazing. Different time zones wise, a little bit tricky to get everyone on at the same time. So we are looking at in the future doing them in different time zones, or offering replays and things like that. But we had a lot of questions around, will this be recorded? So if you're here, obviously you've caught most, hopefully all of it. There will be a recording sent out for you to watch again if you need to. Another comment saying, thanks guys, great show and tell. Good job, Oscar, Anthony, Christy. Looking forward to the opportunity to give it a whirl. So you can grab a 7-day supervisor trial. If you're not a supervisor user, then you can get access to that as well. And as Anthony said, this will be coming out in 8.14 in the next month or two. I'll just double check we don't have any other questions. One last question, and then I think we can probably finish up. Blind test was referred to take out a percentage, i.e. 20%, and test simulated values with simulated ones.
Yeah, that's, you mean referring like some sort of cross-validation? We can do that, yeah, sure. With the amount of data that we have, I'm not expecting any surprise. You can see that the simulations reproduce quite well the drilling data that we had, and we reproduce the distribution, so should be fine. Confident on that.
So there's just an addition to that comment. Christy has said, sorry, I meant simulated values with real taken out.
Yeah, no, I got it. Yeah, it's like some sort of cross-validation. Yeah, it should be fine.
Yeah. All right. Well, I think that was probably everything from us. I'm going to swap back to our presentation. So thank you so so much, everyone. If you had any other questions, as usual, you can send us an email, connect with Oscar and Anthony on LinkedIn as well. We're sharing, different content about what we're up to, different new features, blog posts. I know Anthony's been sharing a couple of great videos lately, which is great. But yeah, that's all from us. I don't know if Oscar and Anthony had anything else that you wanted to add.
I would like to thank you to attend the webinar today. It was great. I hope you enjoyed the presentation and the results. Yeah, keep in touch.
Yeah, same. Thank you, everyone. Thanks, Christy, Oscar. Thank you to the client that allowed us to use the images, and thanks everyone for coming along. Like Christy said, we hope to do more of these and bring you some more interesting information about what we're working on and what we can bring into Supervisor. And just, yeah, thank you again.
Awesome. We'll have a nice day, evening, or wherever in the world you are. Thanks, everyone.
Right. Yeah. Thank you.